Let there be light. It's amazing the difference a simple switch can make. 1 minute you're in the dark, and suddenly everything becomes clear. I thought so. The heating's turned itself off. Well, I'll soon do something about that. Time switches like this one are all very well, but you've got to show them who's really in charge. It'll switch itself off. That's clever, that is. Right. Let's see what exotic delights the television can offer me.
From Buckingham Palace, they inspected the troops on parade.
What we need in the future is the crops, not... In Durham, pleasant though it is, and be a true scholar. You've got to get out.
Not a lot of choice, really.
With the telephone at home, I can pass messages to any one of the 300 million telephones all over the world.
Good afternoon.
Another switch.
No, can I help you?
And this one actually works other switches inside the telly.
Would you like to read the advert for me?
Right.
Too loud.
Mr. Max Mason wishes to...
Useful things, switches. They give you a bit of control over things around you. And nearly every house has some very important switches in it. And every car. And that reminds me.
Yes?
I forgot to switch my headlights off. Ah, well. This battery is just one part of an electrical circuit that these young scientists are putting together. They also need wire, a bulb, and a switch.
Right, you do that one. Yep. I'll connect the bulb. I'll do the switch. Yeah.
The bulb will show when all the wires have been correctly joined together.
Right, the bulb's in. You can try it out now.
Closing the switch allows electricity to flow from the battery and through the bulb.
The bulbs, put it onto the negative.
Switches can be more complicated than just on or off switches. These scientists are making a switch that will let them choose which bulb to turn on. When the switch is correctly joined up to wire and battery, it can turn on the red light.
Red, yes. Red lights.
Or the amber.
Amber.
Or the green.
Green. Works. I like that. I'll put the propeller on.
This fan is turned by an electric motor. The motor is controlled by an unusual switch.
Forward. Backwards.
When the switch is changed round, the fan goes backwards.
Backwards. Let's go.
This is the sailing ship, the Great Britain. And these flags are one of the oldest methods of passing messages from ship to ship. This is an Aldis lamp, and it's sending me a message. The bulb of the Aldis lamp can be hidden by a shutter, which is controlled by a switch. The switch lets the sailor produce either long or short flashes of light.
Flags. And.
Those long and short flashes are part of a code called the Morse code.
Used. For. Long break. More to follow.
Flags and lamps are used for sending messages at sea.
But not in fog.
But not in fog. Oh, right. In fog, you could flash away with your Aldis lamp as long as you wanted, but nobody would know what you were trying to say because you can't see flashing lights in fog. But you can hear sound. The whole business of sending and receiving messages was made much quicker and surer by using electricity, a switch, and sound. Long before the telephone was invented, a man named Samuel Morse, the same Samuel Morse that invented the code, developed a switch that let you pass flashes of electricity, pulses of electricity, along a wire. And it also let you control the length of those pulses very accurately. The pulse would pass from the switch along the wire to a receiver. The receiver changed the pulse of electricity back into sound. The problem was that the person sending the message and the person receiving it had to be linked by wire. No wire, no electricity, no sound, no message. So suddenly wires were being put up everywhere to link towns or countries or even continents. In 1850, a cable was laid under the channel to pass Morse messages from Great Britain to France. The two countries could communicate through the new electric telegraph. Nowadays, modern equipment is very different from the simple switch that Morse himself used. But the Morse code of dots and dashes still remains unchanged. The Morse code is an international language understood by all. Thanks, Harry. But then, in the early years of this century, a man named Marconi discovered that sound could be carried through the air in radio waves without the need for any wires at all. He had discovered a wireless way of sending messages. And this message was received and sent by radio without wires and with the help of an aerial. Quite complicated messages can be sent using a range of simple signaling systems. In fact, this signaller is part of a team that is passing messages in a way similar to that used for getting pictures back to Earth from satellites.
Don't colour.
A flag in one position means yes, in another position means no.
Green colour.
Yes means colour in a square. No means leave the square blank. The receivers need to know when to start and which square comes next.
Colour.
There are any number of methods of signalling either yes or no. Samuel Morse would have recognized this one. Short for yes, long for no. Using sound signals is fine at any time, but deciding the position of a bat is definitely only for fine weather in daylight.
Colour. 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 Don't colour.
Flashing bulbs like this one will carry messages over any distance with a sufficient length of wire.
Colour. Don't colour. Don't colour. Colour.
If the light is strong enough, then a wire is not so important, at least over short distances.
Don't colour. Don't colour. Colour. Colour.
And after all that, the message. This is the newsroom at the Birmingham Post and Mail. And in here, they're sending and receiving messages from all over the world. Now, a newspaper wouldn't be much good without pictures. So, how can you get a picture to this office from, say, London, in time for the afternoon edition, deadline 20 minutes? A picture of me, for instance. Well, it can be done. First, my picture is loaded onto a special machine. It's wrapped round a drum. The drum turns round, and a tiny spot of light shines onto each part of the picture in turn. That spot and a switch together change the black and white of the picture to small or large pulses of electricity. This machine is the receiver. It's filled with photographic paper and chemicals. And it also has switches to convert the electricity messages back into light, which shines onto the film. So when the machine in London is finished, lo and behold, me, on a photograph made up of thousands of narrow lines, all ready to go to press. Right, let's see how I've turned out. Oh, very dashing. Max Mason had this picture sent from London to Birmingham in 11 minutes to show what happens every day in the newspaper industry. And it's all done by switches.